In this video, we'll look at the motion of charges in conductors and insulators. So charges can move in conductors. What would make a charge move in a conductor? Well, if it's just sitting there, not doing anything, the only thing that can make it move is a net force, right? So if I have a charge and I want a force on it, I need an electric field. So if there's an electric field, that will cause the charge to start to move. Then, how would the charge decide where to stop? Well, for one thing, if there's an electric field, it could move until it gets to the edge. Once it gets to the edge, I guess it could slide along the edge, but at any rate, when it hit a corner, if it still wanted to go that direction, it can't. It has to stay within the conductor. So it will move until it gets to the edge, or as the charges move around in here, the charges themselves change the electric field. And so if the charges redistribute in such a way that the electric field cancels out inside, the field goes to zero, the electric charges will stop moving. So let's imagine that this conductor has an excess of positive charges. Where will they go? If I drop two positive charges in here, drop them both in there, we saw before that if there are two positive charges, there's a force that would push them apart. Right? The electric field lines from one would push out on the other one, so they would push away from each other. So if I put two, they would run to corners. Like that. If I had another one, well, if I put one here, it would be forced this way from that one, and this way from that one. It would run off into the corner. And in fact, as I add more and more charges, they would try to run as far away from each other as they can. What would end up happening is they would collect along the surfaces. So a lot would pile up in the corners. The rest would go just to other edges. So draw the electric field lines for these excess charges. Inside the conductor, there actually won't be any field lines at all, because if there were field lines, the charges would move around until the field lines went away inside. But outside, each one of these charges can create a field. So you would end up with something that looks like this. And actually, where the charges are most tightly clustered together, the field lines are closer together, you'd have a stronger field in the corners than you do on the edges. Now, what would happen if we took this, and the conductor is neutral now, so there's no net positive or negative charge in here, but the charges can move. What would happen if a charged object were brought near? So imagine it's a neutral object, but that means it has pluses and minuses in equal numbers. So if you were a plus floating around in here, and all the pluses showed up here, you would want to run as far away from that as you could. You'd run this direction. If you were a negative, you would want to get close to those. So the negatives will come up this way, positives will go out the other direction. So something like this would happen. Is there a resulting net force between the two objects? Well, you can see here there are a bunch of minuses close to the positives. Now, minuses and positives close to each other, there will be a large attractive force here. As you get farther away, the electric field lines spread out, and the field gets weaker, the force gets weaker. So there is a repulsive force pushing these pluses away from these pluses. So these will feel pushed away by all of the positives here. But these are far away compared to the minuses. So it will be attracted more by the minuses than it is repelled by the pluses. So there will be a net force drawing them together.